Hello and Assalamu alaikum. In this tutorial, I'm going to discuss about factor analysis. The main purpose of factor analysis is to summarize the data so that it can be easily interpreted and understood, the relationship and the patterns of the data set. So how we can understand the relationship and how we can understand the pattern? It is normally by regrouping the variable into limited clusters, and based on the similarity, clusters have been made, right? Based on the correlation, those variables, those factors which have high correlation, they make one group, right? So there are two main factor analysis techniques: exploratory factor analysis, normally known as EFA, and confirmatory factor analysis, known as CFA. So in this tutorial, you are going to learn what is exploratory factor analysis and how it can be performed in SPSS. For confirmatory factor analysis, you can refer to my another video. So let's see what is EFA. EFA is one of the type of factor analysis that uncover the complex patterns by exploring the data set and testing the prediction. So basically, in exploratory factor analysis, when we have large data sets that consist of several variables, by using exploratory factor analysis, it can be reduced by observing some groups, and that group is known as factors. So here we just explore. Here we don't have any prior information that about the variable. Here we just explore that which variable has similarity, and based on that similarity we make one group. And by making variable into one group, we can reduce the data. Also, by using EFA, we can check the accuracy, the validity of the variable, whether the variable is valid or not. So you can check the construct validity. How we can apply EFA using SPSS? So if you are ready, let's start the process. So I'm going to use this data set. As you can see, there are 26 questions and there is no prior information about the variables. So now, by using EFA, I'm going to reduce this data by just making groups, and by making those variable groups which have similarity, which have high correlation with each other. So let's see what is the process, how we can apply EFA in SPSS. So for that, you have to go to Analyze, Dimension Reduction, and Factor. Okay, so let me just display variable names. Okay, here you can see there are 26 questions. So select all the question, because we don't know which question lies under which variable. So let's select all the question and move them into another box. Now one by one you have to use these tools and check the appropriate option. So for the first tool, for descriptive option, let's go open this and check the last option, which is KMO and Bartlett test of sparsity. So check this option and press continue. Okay, so you can see in the next section, in the next option, extraction. Here you can check the scree plot, and now you can see in the extract section, you can see there are two options: based on eigenvalue and fixed number of factors. Okay, so what does it mean? Each variable has its eigenvalue. So if the eigenvalue is greater than 1, it means they can make their own factor. If it is lesser than 1, it means they're unable to make in any group. They're unable to make the group, right? They don't have the capacity. And here you can see the second option, fixed number of factors. When you have a prior information about the variable, when you know that this is the number of factor and these number of factors can be made by using EFA, so you can go for fixed number of factors and write down the number of factors that you want to make. So here, as I have no prior information, I don't know how many factors can be made, I am going with the first option, which is based on eigenvalue. So let's check the first option and press continue. Then go to the third option, rotation, and press Varimax. Continue. And now I'm skipping the scores tool because I don't have to, there is nothing to check. So therefore, I am not using this fourth option. Let's go directly to the last one, options. So here I have to check the last option, suppress small coefficient. So click this. So after clicking this, you can see there is one box. Now it was inactive, but now it becomes active. So here you have to write a value. Let's say I'm writing 0.4. So this value is about correlation. So this is the correlation coefficient, right? So here, as I am discussing about factor analysis, and I've already mentioned that factor can be made based on similarity, based on correlation. So those variables which have high correlation, they can link with each other and make one group. So obviously we need high correlation. So here I don't want those values which are weak. So therefore I'm just using 0.4. If you remember, the value lies between 0.3 to 0.7 is a moderate relationship. So therefore I want moderate or strong relationship. So I'm going to use 0.4. So 0.4 lesser than 0.4, the value which are lesser than 0.4 will be invisible in the table. So let's press continue, and now all set. Press OK. Okay, now we have done factor analysis, EFA, right? Now let's see how we can interpret the result. In order to interpret the output of exploratory factor analysis, we have to understand few things. For example, there is one value, Kaiser-Meyer-Olkin measure of sampling adequacy. So the threshold of KMO value is equal and greater than 0.7. If the value of KMO is equal and greater than 0.7, that indicates that the sample we are using is adequate, right? So this is the threshold of KMO. Now here, the Bartlett test of sphericity. Here we have to see the significance level, and based on the significance level, we can accept or reject the hypothesis. One thing we have to remember, that when the significance level, for example, significance level, we have this chances of error 5%. If the significance level is greater than, if the value, the result is greater than the benchmark, which is 0.05, so we can accept the hypothesis. Whatever the assumption is, we will accept this. But if it is lesser than 0.05, we are going to reject this. So Bartlett test of sphericity hypothesis is that correlation matrix is an identity matrix. It means that variables that we are using, they are completely unrelated, right? So one by one we have to see the variable, and then we have to see whether one by one we have to see the values, and after that we will see whether the values are meeting the criteria or not. So let's see the output. So as you can see the first table, in the first table you can see there are two values: Kaiser-Meyer-Olkin, measure of sampling adequacy, in short KMO, and Bartlett test of sphericity. So we are going to take decision based on the first and the last value, right? So as we already know that the threshold of KMO is 0.7. It should be 0.7 or greater than 0.7. So as you can see here, 0.889, which is greater than 0.7. So with the help of this value, we can conclude that the sample that we are using is adequate. It is sufficient to make factors. Now secondly, we have to see the significance value, this. And here for the Bartlett test of sphericity, we have a hypothesis. We have assumption that the correlation matrix is an identity matrix. That means all the variables, all the questions that we are using, they are completely unrelated with each other, right? So here, if the value is, the significance value is greater than 5%, that is 0.05%, we are going to accept the hypothesis. If it is lesser than 5%, we are going to reject the hypothesis. So here in this case, by seeing the significance value, we are going to reject the hypothesis because it is lesser than 0.05, and we will conclude that we have related factors, we have useful variables, so that we can make we have related variables so that we can make useful factors. Now the second table, it is about communalities. So here in there are, as you can see, there are two columns, initial and extraction. Initial are the expectations, the expected values, and the extractions are the real values. So these are the correlation values, and it is showing that how much one question, one variable, it has the capacity to make their own group. So here it has 67%, 61%. So these are just for the sake of information. We are not going to take any decision from this table. Let's see the third table. If you remember, while just checking the appropriate, while just starting the process and checking the appropriate option, I mentioned that if the variable has eigenvalue greater than 1, that variable can only make the factor. So as you can see, the eigenvalue, the first column, here you can see those variables which have eigenvalue greater than 1, only they have made the factors. So if you want to know that how many factors are there, you can count down the rows, and by counting the rows and by just seeing the total eigenvalue, you can assume that how many factors have been made. So let's see the scree plot. Basically, this scree plot is a graphical illustration of this table, total variance explained. So if you sketch an imaginary line from 1, so here you can see there are some circles. So if you sketch an imaginary line with first, it means eigenvalue. So above the line, above the one line, you can see, you can count different circles. So those circles are factors. Okay, now we have to see rotated component matrix. This is the most useful, and it gives a lot of information about factor analysis. So this is rotated component matrix. Now you can see it is showing like question number 1 till question number 5, the values are lying in a series. So it means it must have some relationship. That is why it is lying in just one series. And if you can see the rows and in the columns, there is no other value lying in it. So it means from question number 1 to question number 5, this is one factor. Now let's see. Similarly, you can see question number 6 to question number 10, all the values are lying in just one column and there is no other values. So here we can conclude that question number 6 till question number 10, they have made another factor. The third is about is starting from question number 11 till question 16. But here you can see question 11 till 15, it is fine, but in question number 16 there is a problem. If you can see the row, there are two values lying. It means this type of value, this type of situation is known as, these are cross loadings, right? And it means there is some problem. It is not actually, this question number 16 is not actually measuring only this type of variable, whatever the variable is, this only this variable, the variable number 1, but it is also somehow it is also measuring this 6 factor. So it means there is a cross loading and there is some problem in this question number 16. So we have to see what is the problem, and if the problem is not if it is not rectifying, then we have to exclude the question from the data set. Now from question number 17 till question number 21, everything is fine. All questions are lying within one group, but only one question is problematic, which is question 21. See, it also has some cross loadings. Now question number 22 till 26, there are two questions which have some problem, because 2 questions are lying in another group and only 4 questions are lying in one group. So now we have to see, so in exploratory factor analysis, what we do, we exclude those questions which have some problem. So one by one I am going to exclude question and we'll see whether it is making a group or not. So let's see. Let's go to the factor analysis window again. Here we have question 16, which is actually creating problems. So let's go to question 16 and send it back. So it means I have excluded question number 16 from the analysis list, and then again press OK. Now see, go to rotated component matrix and see whether it is fine now. So question 11 to 15 is fine, question 21 to 26, but now there is no problem because all questions are lying within their own group. And now you can see, before that, before excluding question 16, it was making 6 groups, but after excluding question number 16, now you can see it is reduced as 5 groups. It means 5 factors. So it means this is our factor, and now we have reduced the bulk amount of data into different groups. So now we know that question number 1 till question number 5 is group number 1, question number 6 to 9, 6 to 10 is group number 2, 11 to 15 is 3, 17 to 20 is 4, and 21 to 26 is 5. So now we have to reduce these data into some subsets. So now I have to make some cluster. So let's see what I will do. In order to make these amount of data and in order to reduce the data, I am going to compute the variable. So let's say, what is the process of computing variable? Let's go to transform, compute. Here I am going to compute variables which are similar, and I'm going to make one composite variable. So now, for example, these 5 questions, now I'm going to compute all the 5 questions and it will become one variable. So by doing this, what I am doing, I'm just reducing the variable and I'm making clusters. So let's say I'm giving name G1, that is group 1. So let's open the bracket, one by one compute each question, those questions which are similar. Question 3, question 4, question 5. Then divide it by total number of questions and press OK. Now again, you have to follow the similar procedure with other questions. So by following the same steps, I have computed all the 5 groups. So these are different 5 factors, and now I am going to use these factors to predict the model. I'm going to use these factors in my further analysis. Thank you.